Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Soroush who has just completed the course Linux Basics for Robotics and he'll be giving us a presentation on that. So first of all, we would like to begin by seeing his code base running on the real robot, and then after that we can get into the nitty-gritties about his project. So without further ado, let me hand over this platform to him so he can begin his presentation. Alright, Sarush, whenever you're ready.
I'm ready.
Okay, let's go for it.
Okay. Now here we have the real robot. So I already run the first to the robot interface, and also here we have the obstacle avoider,
Mm-hmm.
and also here we have the robot statistics.
Mm-hmm.
So it's going to start by a linear speed, I think about 0.2, and then also the linear speed of 0.05 and also the angular speed of 0.5.
Mm-hmm.
And so the algorithm is like it's going to scan the front left and front right, and then if the path is clear, as you can see here, it's going to move forward.
Mm-hmm.
So the path is clear and it's going to move forward because it's the front rear, front right, front left, and front is also less than the threshold, which the threshold is 0.1
Mm-hmm.
meters. And also because sometimes it's going to go to this corner and it's going to just turn around a lot and it's kind of stuck there. So I started to limit the angular speed of 0.5,
Mm-hmm.
and it's just going to turn time of 0.3 seconds. So it's just going to turn a little bit like 90 degrees.
Mm-hmm.
And calculate like this one by trial and error to see what angular speed with what amount of time it goes to 90 degrees.
Mm-hmm.
But still, at some points I have the problem because in simulation it's going to smoothly go towards the path. But here in the real robot, it's not clearly get this amount of information to turn around and not avoid to collide with these obstacles. And I don't know, maybe I don't know why that happened actually, because in the simulation everything is exactly the same, and but I found that in the simulation once my robot is here,
Mm-hmm.
in the simulation is like here. Once it's like this real robot, it doesn't match with the simulations.
Okay, I see.
So far.
Yeah, there are some deep concept that causes that, but I think for now we should rely on the laser scan data that it's receiving, which but I think the ROS2 basics course will probably do justice for you on that one. But yeah.
Yeah, because you can see here, for example, it's not getting the, for example, now front is blocked,
Okay.
and my threshold was way, for example, here to turn right,
Uh-huh.
not
So
here.
it did manage
But in
to
simulation was, yeah,
in simulation it did manage to avoid that wall.
yeah, it's going to turn right exactly. But here you can see it's not. And also I run the simulation and the real robots together
Mm-hmm.
to see what is the problem.
Mm-hmm.
And I saw that, for example, when the robot in simulation is like at the end of the path, in the real robot is like in the middle of the path.
Okay. So when you changed the threshold, what did you see? What did you figure out?
Uh, I I played a lot with the threshold here, for example, point 4, point 0.5. It somehow goes well, but suddenly it's also because, for example, it's in the middle of here,
Mm-hmm.
and the front is like very clear. It's going to turn.
All right. So can you stop what it's doing right now? So we move it to a different place and
Yes,
try again.
yes, sure.
So yeah. Then try take it out of the corner, and then we can see what's going on. Then try moving it to the pedestrian path. Pedestrian in. Yeah, no, the other one on the. Yes. Right. Okay. So yeah, leave it there, right? And then you can try maybe refresh your whole ROS-ject, so you can close and reconnect. Or no, I mean like close your whole ROS-ject, right? So you can close the whole tab, right? Or control shift R, so that the whole window refreshes, and then you reconnect to the robot afterwards. All right, so as we wait for that,
I didn't do this maybe because sensor readings was there, so I should just
yeah,
to reset everything, right? Because I went to, for example, in simulation, I press Command R to just reset everything.
okay. But it didn't. Okay, so right now, are you connected to the robot? So can you give me one sec? You're still connected. Okay, disconnect. So press the tab so that you disconnect. Oh, it's still running your node. Can you terminate that node first?
What do you mean? Oh, this one?
Yes, can you terminate it? Yes. Yeah, you terminated, right? So
Yes.
now you can reconnect now. Right, okay. Okay, let's connect again. Okay, you can start the whole procedure again, and let's see. So Okay, let's see if it avoids the wall this time. It still fails to do. You're still using a threshold of 0.3, is that right?
No, 0.1.
0.2, 0.1.
Yes.
Okay, why?
In simulation, it works 0.1. So try to because it's
Yeah, well, there's a difference between, so in simulation 0.1 might work, but on the real robot it's hardly 0.1. So did you try using 0.3? What happened when you used 0.3?
in 0.3, for example, in simulation, it takes a lot of time, and also it's going to turn a lot. But in 0.1, for example, it's going just directly here, then turn right, then again goes all the. It's like very smooth for me, so I just try to use 0.1.
Did you at least test it with 0.3 on the real robot before this?
Yes, yes, I tried 0.3, 0.5, and all of them. And for 0.3, I don't know. It's
Mm.
going to turn here and then turn around and then goes here
Mm.
and stuff here. So I just maybe I saw that maybe 0.3, because if it's 0.3 here, I figured out that if the slide is going to turn right, still the scanner is going to like lasers this one here, because the front left and front right is like here.
Because this
And the
this is supposed to be happening in your like obstacle avoidance procedure, right? It's supposed to notice what's close and avoid it despite where you start, right? So let's have it start from a different corner. For example, let's have it start from the corner that's close to the timer that we have there,
like here.
bottom left. Yeah, or on the, if we're looking on the camera screen, so bottom left on the right screen.
Oh, okay.
Oh, I think that one is frozen. So can you press play on that window, the right window for the camera? Yes.
Yeah.
Yeah. Let's see if it starts from there.
Yeah, like for now, I will use 0.4,
Mm.
and from the beginning, it is going to say alpha blocked. So I'm going to turn right, but still I. So what is the reason that in 0.1, for example, simulation works, but here is not working?
Um.
Because of the delay and the latency between the real robot and the terminal that we got that information.
Yeah. We could say that. Yeah, we could say that because, well, the 0.3 just gives it enough distance to stop, right? So, and there's also the the control loop that checks that the robot has reached 0.3, right? So how long does it take for that control loop to respond to stop the robot if the 0.3 threshold has been reached, right? So there's also that as well. So there are a couple of things that are being taken into consideration, right? But you also want your robot to turn with enough room for it to rotate, right? Because
Yes.
it's got things that extend from the to the left and to the right of the laser scan sensor. So yeah.
Mm.
There's that. That's why I was worried when you said you used point 0.1, because if it's point 0.1 and your robot has got a radius of point, let's just say 0.5 or 0.35, right? Then point 0.1 means it won't be able to rotate either left or right, because when it tries to do, the other side touches the wall. Yeah.
Because the point 1 is kind of laps this one with the wall.
Yeah. So this is a threshold of 0.4, and it's still trying to figure out which way to go. I think it should go now.
Yeah.
So
I think because now you can see it's like 0.401.
okay, all right, and
because in my control loop I have that if, for example, front is clear and if front right and front left is also clear, go with front, because I prefer to go more in front rather than turning.
Okay.
And now here the front right is like less, but front still is in the range, so it's going to go front.
All right.
Forward.
Okay, so at every time that your robot has to make a decision of whether it should set the velocity values, it always makes that decision based on one index, right? So the front index.
Yes.
Okay.
If the front and front right and front left, all of them are clear, so prefer the front. Otherwise, goes with the highest distance. For example, if the front right had the more thresholds, go with that.
Okay. So let's try run it with 0.3, because this is 0.4, right? And we see that it's barely making any progress. So let's try 0.3 and see. Yeah. Okay. And can you tell me something? So when your robot moves, right, how do you determine for how long the robot moves, right? So if you set a linear velocity of, let's say, 0.1, for example, how do you determine for how long it's going to go at that speed?
I calculate the time to move. So it's like front minus the threshold that I set, and divided by the linear speed minus some threshold.
Okay.
Just have the clear path that it's not going to lapse.
All right.
And also the whole process of simulation is about 5 minutes. So after 5 minutes, I is going to stop everything.
Right.
So I think it's necessary to have something that the robot just be in the loop and continuously works.
Okay. So I hear you referring to simulation most of the time. So because this is running on the real robot, did you make any changes to those parameters?
Yes. For example, here I think on the real robot 5 minutes was too short, but in the simulation it's going to go forward all the path. But in the real robot I make it like you can see here now it's like 10 minutes, but in simulation it's like 5 minutes.
Okay. So I see. So you were hoping that after 10 minutes it would have managed to at least encounter every obstacle and avoid it, hopefully.
Yeah.
Okay. All right. Yeah, it would be very nice to at least see it avoid like the wall and not be stuck in a corner. That's why I've been trying to like let us start from a different place so we can get it to move. Right now it's not really moving, so I'm gonna kindly ask you to move it to a different corner again so we can see it. Okay, now it's moving. Let's see. It's still a little bit slow though, but yeah, we'll see. I think the other window is not refreshing, so the window on the right, oh, now it is. You paused one of them. Let me see. Okay, try play all of them so we can see.
Yeah.
Okay, there is a claim that the parameters have been set successfully, but we don't see any movement. Okay, now it's moving.
Yeah, it's like I put it like this because I put it like continuously, but I select. Sometimes it's not going to reach the exact half of the level. You can see it's going kind of collapse with the wall, so I put it like this to make this bit going forward instead of continuously goes.
Okay, what's your linear velocity? What values are you setting them to?
It's like 0.05.
Okay, it's probably
0.1.
yeah. So I think half of
For example, was here I figured out maybe 0.05 is better to give more time. That's why it's kind of slow.
yeah, and also it becomes very difficult to really see what it is doing, right? For example, the time that I was saying, it shows, the terminal shows that the parameters have been set successfully, so but then we don't
and then it's
get
going to start.
yeah. So did you try the 0.1 value before you moved down to 0.05?
Because I tried 0.1, maybe with the threshold of 0.1, and maybe that's one we don't have enough. Because I said, for example, here it's going to set the speed, and then it's kind of hit the wall, and then starts to measure all the other sensors again.
Because I see.
The threshold I think was too small for 0.1 linear speed.
Well, I wouldn't say that exactly, but because the speed is generally, it is very low, so it's not supposed to be the threshold itself that's actually affecting how it perceives obstacles or when it stops, right? Because for as long as it's within the bounds of 0.1 meters to the wall or to an obstacle, it's just supposed to stop, right? But I think the loop that is responsible for setting the linear velocities or angular velocities is what is not refreshing fast enough, or maybe you're not capitalizing on the distance values that you get. So when you get when it considers the front to be free and it's got this particular distance, for example, let's just say 2 or 1.5 meters, right? It's supposed to use the whole distance before reconsidering how far the obstacles are, because the assumption is the whole 1.5 meter distance is free of obstacles, so I have to go for that long. But right now we see it's constantly stopping and checking, right? Even if there are no obstacles in front of it. Yes.
I tried the first album that you mentioned that it's going, if the pass is total, just go that amount of time.
Yeah, that would have been.
I feel maybe just stop and checking is more safe than that one.
I think it's rather conservative, right? It's because you're not using exactly how much you're getting, because if you constantly doing this, then you are pulling for laser scan data or for any refreshment on the readings when you don't need to poll. You don't need to be checking those values because you got one that gives you a complete certainty of.
Yeah, exactly. Because for example, these two lines should give me that the time to move just continuously goes to the end of the pass and then to recheck again.
Yeah. Did you get it to crash, or did it crash at some point? What led you to have to do it this way, where you have to constantly check?
This way, that's what the problem arises. In simulation, for example, the time to move it calculates, and then, for example, if the robot is here,
Yeah.
in one shot it goes here and then just turn right. But in the real robot, I figure out that it's going to crash all here, and once I check it with the simulation and the real robot in the same time, I figure out, for example, the robot in the simulation is like end of the path, but
Uh,
in the real robot, the robot is like in the middle of this path.
yeah,
Then I figure
because
out maybe there is some.
yeah, I don't think you must rely on that correspondence, because they are not going to be exactly the same, right? Because the values, so the laser scan values or those red things you see in RFs, they will always be true to whether you're running simulation or you're running it in the real environment, right? Those are the ones that should guide. So um, on the basis of that alone, you cannot say because the robot was in the middle in simulation, then I will make an assumption that it will be in the middle in the real world. No, it's not going to be exactly the same. There is no direct correlation, even though the environments look similar, right? Um,
Yeah.
yeah, so I think for future purposes, it's important to understand that we cannot really directly translate those predictions to the real environment just like that. Um, but all right, I think for now this is good enough. You can just give a brief rundown of your obstacle avoidance script. That's what I want to really see and why it's doing these things. So I think you have about, let's say, about 2 minutes to do that, and then we have to wrap it up here as a result of time.
Oh, okay. So just explain the whole algorithm a little bit, right?
I want the obstacle avoidance script particularly because I think that is very, very important in this regard.
Oh, okay. So here I have like here I just put that all the sensor has validate and it gives some information. Otherwise, I put like tend to just mention that, for example, some of the sensors are not working.
Mm-hmm.
Then I have like from the statistics, I have these amounts of the data
Mm-hmm.
to scan the values, and then it's going to have three statements to check, for example, front left, front, and front right
Mm-hmm.
is blocked or not. Then I calculate the time to move from front minus the threshold, and then I calculate the time to move. And then here for the decision logic, if, for example, I also use this one to just turn to avoid any stop point. So if, for example, if going to just turn, it's just remember that one and avoid to turn again to not just stop. And I will just calculate, I just add another argument for the stack count to figure out if it's going to stack and how many times it's going to turn around.
Mm-hmm.
Then if the front is not blocked, then it's going to just move forward. And if the front wheel is not blocked, front left and front right is not blocked, it's again going to moving forward with the linear speed and the time to move.
Okay. Okay.
And then if the front left is blocked and if the front is blocked and if all of them is blocked, like I said, it's the count and all front are blocked, then I calculate the start count, and if greater than the maximum start count is like it said that it's stopped, and then set the current velocity of minus to just goes a little back.
Mm-hmm. Okay.
And I think then this is the best to just avoid stuck at the corner. And so here is like calculate them again, and here we have the if for turning decisions at the left minus right, and then calculate this, actually set the angular speed of 0.5 for the amount of fixed amount of time that is now here. I think it's 0.3, yeah, it's 0.3, and then I have if, yeah, all of things like the same. And yeah, here is also if the last one, for example, is turned right, then I'm going to just set the angular speed again, and it's again another one to just remember what is the last term and do the opposite, to just not going to stop it again.
So in these moments that you have to, are you setting the linear and angular velocities to zero when when your robot has to do these decisions? Do you have the moment where it has to set these values to zero and reconsider which parameters to set linear and angular velocity to?
Yeah, here for example, first I set the time velocity, the linear velocity to 0,
Mm-hmm.
then calculate the difference, and then assign the angular speed for the fixed amount of angular time.
Okay. All right. I think for now, I think we can say you've explained it enough. As a result of time, we have to unfortunately wrap it up here. So I think you hang around and we'll finish our conversation on Zoom. Okay. Alright, everyone, this was Soroush's presentation, and would like to thank him for giving us the details about what he did and how he did it. So, until next time, we'd like to encourage all those of you who would want to give this course a try, and all the other ones that we give certification on, to do so, and then you can come and showcase your work here. So, until then, keep wishing your ROS learning.